Okay, so welcome to the presentation for the new Unity multiplayer system. My name is Sean Riley. I'm a software engineer working on the networking team. This used to be called UNet, and if you see blogs and things, it probably still says UNet. I'm probably going to say UNet during the presentation. Okay, so the new system is currently in development. We have a dedicated distributed team working on it. It's scheduled for the 5.x branch, so it won't be in the initial 5.0 release, but it'll be in one of the subsequent 5 cycle releases. There's a private alpha right now, and there'll be a beta after 5.0 goes out. So the new system is going to replace the old Unity networking system. That system has been around for a long time. It hasn't been updated in quite a while, and there's not very many active users of that system. So when the new system goes in, the old system will be removed, and that includes the RACnet third-party library, which the old system uses. And there was a blog post about this on the Unity blogs site. So the long-term plan for this is quite ambitious. So the first phase is what we call the multiplayer foundation. That's what we're going to talk about today. And the second phase is dedicated servers. And the third phase is more complex multi-system MMO-like games. So phase one, which this presentation is about, uses a 5.x schedule. And it assumes there's no dedicated server. So we're going to talk about what that means during the presentation. So this is the component diagram of the new networking system. So at the bottom, there's a transport layer. In the middle, there's new engine components, a new C# API, and integration with the editor. And then at the top, we have some online services. So we're going to talk about each of these pieces in a bit more detail. So the transport layer, so this is a brand new high-performance UDP network transport layer written in C++ and integrated into the Unity player. So this is a socket-like API. It deals with buffers of bytes. It doesn't deal with network packets that it understands. So this is just for moving bytes across the network. Although, unlike a low-level operating system socket layer, this layer has different levels of quality of service. So you can have reliable transmission. You can have like only the last packet should arrive transmission. You can have unreliable transmission. And so these are we call these channels, and the whole API uses channels. So this is really focused on performance and flexibility. So you should be able to do anything with this layer that you can do with a operating system level socket layer. That's the plan. And this exposes a C# API. This is an example of what transport layer code looks like. So this is an API for network programmers. It looks like socket code. You deal with message buffers and connection IDs and enumerated event types, things like that. So then the next piece is new engine components. We have a network identity. This is a new component that you put on your game objects that gives them an identity across the whole network. Then there's a network behavior. So this is a new scripting-based class. So if your game scripts derive from network behavior instead of mono behavior, then they get all the network functionality. Then there's a network transform, which handles synchronization of movement and physics. And at the highest level, there's a network manager object, which does sort of high-level game networking things like spawn management and connection management. And all of these things are quite extensible. So editor integration, my screenshots are a little out of date, but the editor integration, there's custom inspectors for all the new components. And because debugging distributed network systems is quite difficult, we wanted to expose as much of the internal details of the networking system through the editor components. So it doesn't quite look like this exactly anymore, but you can see that lots of the internals, like what objects exist on the network and what are their IDs and how you get at them is all visible through the inspectors in the editor. And there'll also be integration with the profiler, which is nice. Okay, so the next piece is the high-level API, the networking high-level API. So this is a new C# extension DLL, like the new GUI system. It's a separate namespace, separate DLL. It'll be a Unity networking DLL. And this provides sort of game-level networking services as opposed to sort of socket-level networking services. Whereas the low-level API is focused on performance and letting you do anything, the high-level API is more for doing iterative development of games and quick development. So it's focused on quick turnaround time and making things easy for developers. So high-level code looks more like this: spawn a bullet from the server. So it looks like game code rather than socket code. And in our demo today, we're going to be mostly writing high-level API code. Okay, so the next piece is online services. So once your multiplayer networked game ships, this is what you use for operations and running your game. So these are things that are hosted by Unity that are in the cloud. There's a relay server that lets you have serverless internet play. So this is like a proxy server, so all the traffic gets routed between the clients, so you don't have to have public IPs for all of the participants, and it gets around problems like NATs and firewalls. There's also matchmaking services to let people find other people to play games with and join games. And there'll be concurrent user tracking and reporting. And the interfaces to the matchmaking services are, there's a web service interface, and then there's a C# API that wraps up the web service interface. So matchmaking code looks like this. You create a match through the matchmaker, and then you get a callback saying your match has been created, and here's the info you can use to join the match. Okay, some high-level API concepts. So this is just vocabulary to help us as we go through the rest of the presentation, the demo. So the high-level API is server authoritative. So every game has to have a server and can have clients. But when there's no dedicated server, one of the clients is also a server. So we call that process the host. And you can see from the diagram that the host runs a server and what we call a local client, whereas the other participants just run a remote client. And it's nice, this works out nicely because the local client and the remote client run pretty much the exact same code. So you don't have to worry about it when you're writing game code about, is this client on the server or is he remote, because it's all handled for you. Instantiate versus spawn. So most of the people on the networking team come from companies that make mostly exclusively multiplayer games. So we had a little bit of a vocabulary conflict here. So this tries to clear that up. So in Unity, these terms usually mean the same thing. But in the networking API, instantiate is a local thing that happens. And then spawning means that an object has been created on the network. So it gets created on the server and then spawned out to all the clients. So we call that spawning, where the instantiation is just like creating a game object locally. And there's a spawning system which manages the distributed object lifecycle. So if an object gets just deleted on the server, then it gets deleted on the clients. There's a quote: adding multiplayer to a game at the end of development really means adding it in the middle. This is an old quote, but still pretty valid, but we want to change this. Okay. That was pretty fast. So now we're going to take a single player game and we're going to make it into a multiplayer game. This is going to be a live coding exercise. So our single player game is a simple 2D top-down shooter. So we'll do a quick tour of this game. So here's the Unity editor. And my game window's at the bottom here. And my spaceship can fly around and shoot these little aliens. So we have health bars, we have bullets. That's about it. So pretty simple game. So this game has one scene. Let me start at the top. There's one scene, and you can see here it's got a bunch of obstacles in it. It's got some sprites, 2D sprites. It's got some materials. It's got 4 prefabs. We have a ship prefab, we have an alien prefab, a bullet prefab, and we have an explosion. Each of these is pretty simple. It's just a sprite renderer, 2D collision, 2D physics, and we have a control script on a ship, and we have a combat script. And the combat script is on both the ship and the alien. And then we have a bullet. It's got a bullet script on it. We also have in the scene, we also have a spawner, which creates the aliens. And we have a little game manager, which just keeps track of scoring. So there's 6 scripts. There's a couple of sounds, but I don't have audio hooked up. And that's about it. So a pretty simple game. Okay. So this is what we're going to do to make this into a multiplayer game from a single player game. So let's get started. So the basic hookup is network identities and a network manager. So let's go to our prefabs. Here we go. So our ship, I'm going to say add component, go to the new network section of add component, and we're going to pick a network identity. So now the ship has a network identity. So the same thing for the slime alien, and the same thing for a bullet. Network identity. So there's not very much to configure on a network identity. There is one flag to say, is it a server-only object? There is some preview information, which there's nothing here yet. Well, there will be more data there when we start running things. There is an asset ID. Asset IDs are used to identify prefabs across the network. Okay. Okay, so we added some network identities. Let me go back here. Oops, wrong window. Then we need a network manager. So the network manager, let's create a new game object. And I'm going to rename him to be network manager. Now when I go to the add component menu on the network, there's a network manager component. So this guy's got some more configuration on him. Open these up. There's some network stuff in here we're not going to worry about. There's some flags here. Don't destroy and load. So we want your network manager to persist across scene changes. Network gizmos, that's a debug thing. Running background, it's just sort of a safety mechanism. It's a common mistake for when you're starting up a new network game project is to forget to set running background, and then if you're running 2 instances of Unity on the same machine, one of them will stop running when you switch windows. So it's just a bit of safety there. We have some scene management here, and then we have spawn management. Here we go. So I'm going to open spawning up. So there's a slot here called the player prefab. So I'm going to drag our ship prefab into that slot. And then I'm going to add a couple of slots here. And, oops, sorry, my trackpad is not a very good dragging instrument. Network manager, spawn. Which one did I get? Bullet. I think I have to add the ship too. Okay. So this registers those objects as spawnable across the network. Just save that. So the ship object in the scene, I'm going to delete that because the network manager is going to spawn ships for us. So now the net manager is in control of spawning. So anytime a player enters the game, it's going to spawn the ship prefab for that player. So let's just run it in the editor and see what happens here. Nothing. That's because the network isn't running. So usually you would have some kind of in-game UI to say start a network game or start a local game, start a single-player game. But we have a helper API, a helper class here called the Network Manager HUD. And this gives you sort of a development API for doing those things. So I just started up here and we can see I have a new menu in the game window. And I'm going to start as a host. And remember, host is the server and the client in the same process. So when I start as a host, now we get a ship. And my ship just works as usual. Since we haven't changed anything, everything just works. Okay. So let's see what happens if I build a player. All right, so there's a player running. Let's run 2 of them. Okay, so I'm going to make the one on the right is going to be the host. This is my convention here. So I run the host. There's my ship. And this guy can start as the client. And we saw another ship appear, but things aren't working yet. But if I log out of the client here, you can see the ship disappeared. So it is actually spawning the ship for the new player. It's just everything isn't hooked up properly yet. So, okay. So that's our basic hookup. I'll go back to my presentation. Oops, wrong one. Okay. So spawners, scenes. Okay, there's one more thing I need to hook up. So also in the network manager, we have some slots here for scenes. So in addition to spawning, the network manager can do some scene management. So I'm just going to drag my space scene into here. It's not working. Why is that? Okay. Just have to add this to the build settings. Now it should be okay. Okay. So these 2 different scenes here, offline scene and the online scene, can control what happens to your game when the state of the network changes. So it'll automatically switch to the offline scene if you're in a game and you lose your network connection, for example. So got that set up now. Okay, so player movement. So let's go back to our ship prefab. We have a control script on here. I'm going to open that up. I have Visual Studio integration set up for this project. So this is the script open in Visual Studio. Do a quick tour of this script. Check my time. Okay, so this is a movement script for a ship here. You can see we use the Unity engine networking namespace, and this script is derived from the network behavior, not the mono behavior. So the ship has a fixed update function where it applies thrusting and acceleration. Then it has in the update function, it handles arrow keys. And then if your arrow key state is different than your last frame's arrow key state, it calls do thrust to set the movement settings. Then when you press the spacebar, it fires a bullet, and then it centers the camera on the ship every frame. Now this explains why our camera was all messed up when we just ran this code before, because there were 2 ships in the scene, and both of them were trying to set the camera to their current position every frame. So we need to know which is our ship and which is not our ship. So the network behavior class that we're derived from gives us ways to do that. So we have on our base class, there's a isLocalPlayer member variable, which I can check. And in this case, I want to say, if this is not the local player, then we're going to just return from this function. Oops. So none of this code below will run if this is not for my ship. And I want to do the same thing for fixed update. And I can build that. Okay. So then I need to also add a network transform to my ship. And this is the new network transform component. It's got a slider here for the send rate, basically how often a network update's sent for this object. It's got some other configuration like which channel to send data on, and then there's some tweakable variables here. I'm going to check the local player authority checkbox. So that means that movement for this object is controlled by the client that it's owned by. So this player controls movement for his ship. So that client will send movement updates to the server, and the server will propagate those movement updates out. So the other model would be a server authoritative movement control, where the client would send messages to the server, and then the server would move the object. But in this case, we want a very responsive client movement, so the client's going to control the movement of the object. Okay, so our ship has a network transform, it has a script tweak, so we should be able to run it and see what happens. So okay, I forgot something. I'm just going to turn off the aliens because they're going to get in our way right now. So there we go. Turned off the alien spawner. Okay, so this is going to be our host. This is going to be our client. So this one I start as host, fly a little ship a little bit. This is our client, and now we can see our movement is synchronized between the two machines. And if this guy logs out, oh, we didn't see. He wasn't on screen. Oops. But when he logs back in, he appears and disappears. And the other ship's in the correct place when you log in. It's significant to note that all of this is set up for joining games in progress. So all of the state synchronization, movement synchronization is set up so that if you join a game that's already running, the clients will get the latest state of those objects. So you don't have to worry about, the old networking system had a thing called buffered RPCs, and you had to manage the lifetime of those. And all of that happens automatically with the new system. So if I fire some bullets, oh, that's not quite working. It's only firing bullets on my local machine. All right, I think we've successfully moved to the next slide. Okay, local players, network transfer, shooting bullets. Okay, the next step is shooting bullets. So let me go back to our ship script. So in our ship control script here, we have a function that gets called when you press the space bar, and that function here is do fire. And what that does down below is it just creates a bullet from the bullet prefab and shoots it off with your current direction heading and then destroys it in 2 seconds. So right now that's happening on your local client. You press spacebar, a bullet gets created, no one else sees it. So what we need to happen is that should be created on the server, and then the server will tell everyone to create the bullet. So the way to do that with the high-level API is a thing that we call a command. So I'm going to change this function to be a command function. Command functions run on the server. So now I've changed this to say command do fire. Right, this command attribute is a new custom attribute that lives in the Unity networking namespace. So now what happens is on the client, instead of that function being called locally, the arguments to that function and the function call will be sent to the server, where it will automatically be deserialized and then run on the server. Oops. So then the bullet will be created on the server. So that's not quite enough. We need to say, then have the server spawn that bullet. Remember we talked about the difference between instantiation and spawning. Now we're saying the server is going to spawn the bullet so the other clients will see it. So that it's as simple as saying network server.spawn bullet. And because we registered our bullet with the spawning system, clients will know how to create the bullet. And with the state update synchronization, all of the state will automatically be applied for the bullets. So let's try that out. So this is going to be my host. This is going to be my client, or trackpad. So now when I fire, oh, we've got some problems there. What's going on? It's not quite working, but you can see it's trying to work. The reason it's not working is because the bullet doesn't have a network transform. So let me go here and say add network transform to the bullet. So the bullet now, so the bullet needs to be spawned at the right position, and it also needs to be spawned with the right velocity. And it wasn't being spawned with the right velocity, so it was just sitting there. So you would like immediately drive into your own bullet after it was created. So we set up a network transform on this on the bullet prefab. Now it'll be created with the right velocity and it'll move around. We don't need to. We can tweak this a little bit. We don't need rotation for a bullet, so I'll turn that off. And bullets are not local player authority, so that should be fine. Okay, try again. Oops. Okay, so that's better. So now bullets have been created. Let's try this guy as well. When the host creates a bullet, you should see it on the client. Yeah. Ooh. So the next thing is that damage is not working properly. So we just killed the player and he respawned on both clients at the same time in different positions. He had different amounts of health. That's no good. Okay, so we got through this one. The next thing is health. Because we started late, I have to keep checking my time here. I'll just keep going. So we want health to be controlled by the server. It says server authority of high-level API. So the way to do that is let's go to our combat script instead of our control script. So the combat script is the thing that puts those health bars on everything and makes them explode when they run out of health. It's on both the aliens and the ships. So we made this a network script as well. So we want health to be a server-controlled variable. So there's another custom attribute I can use here. We call this a sync var. So a sync var now is controlled by the server and will be automatically propagated to clients anytime it changes. And also, the join in progress applies to sync vars. So if you join a game, you'll be sent the latest value of the sync vars. So since health is on the server, we need to do a little bit of script editing here. So we want to take this take damage function and say if, in our base class again, there's a function I can use here, or a property. I can say is server. So if this code is not running on the server, then we want to return. Oh, we don't want to scream it. Return. So that means that damage will only happen on the server, which is good because the collisions will still happen on the client. And let's take a quick look at the bullet script. The bullet script says, if I hit something and it's got the combat script on it, then call the take damage function. So that'll still run on the clients, but when this guard here gets hit, it'll just return immediately and nothing will happen. Okay, so let's try that out. This is our host, and this is our client. Okay, so if I shoot him, we should see his health go down. We didn't. Live demo. I'm not sure I saved my script. Try it again. Okay. We might have to do some live debugging. That could be exciting. Okay. So there's my ship. I shoot the other guy, and there his health goes down. So let me just log out, log back in, and we should see, yeah, his health now is, you get the latest value when you log in. Try the other window, shoot him, and his health goes down. We see we have an explosion. Yeah, there's still some respawn problems and some damage problems here. So when I shoot him, there's supposed to be a little explosion. You can see it's happening on the host, it's not happening on the client. And our respawning is happening in both places, which is a bit confusing. Okay. Okay, so the take damage function now is running on the server. But servers, we don't want to do effects on the server. This make explosion function here just creates a explosion sprite. So we don't want effects to happen on the server, so I'm just going to remove that completely. We want effects to happen on the clients. So what we can do, there's lots of ways you could do that, but one of the ways is to use a hook function on our sync var. So we can say hook equals on damage. And then we'll make a function on damage, and give it the same type of arguments as the sync var. So now, anytime on damage, anytime health changes on the server, that value, the new value will be propagated to clients, and the on damage function will be called on the client. So we can say make explosion. I should use code complete, and we'll do a short explosion on the clients. And again, if you think back to our host model, we have a local client and we have a remote client. The hook function would get called on the local client and the remote client. So on the host, you'll see exactly the same thing as you see on a remote client. So I need a little tweak to that. Let's just say if new health is not equal to 100, which I know is your maximum health, do the explosion. And then I have to set new health. I have to set health to new health. When you implement a hook function, you replace the standard function that would do this assignment. So you have to do the assignment yourself. And this, having access to both the old value and the current value is actually useful there. So you can do diffs. You can see how much your health changed or how much damage was done. Okay. So now we should see our explosions. Respawning is a little different. Well, let's just try that. Okay. It's our host, and it's our client. Oops. Client. So now we should see an explosion. No? Demo fail. That's sad. Did I... I'm just going to go forward. I don't have time to debug right now. Assume that worked. Pretend that worked. Okay, death and respawning. So when your health reaches 0, the aliens just die and explode. The player object respawns in the middle of the screen. So there's a respawn function here, and it sets health back to maximum health, and it moves the ship and sets velocity back to 0. And okay, so in our networked environment, we need to change this a little bit because health is controlled by the server, and in our local player authority model, movement is controlled by the client. So what we want to happen is for the server to set the health. So our take damage function happens on the server, so I'm going to say health equals 100. And then we want the respawn function to be called on the client. So this is the opposite of a command. This is a function that is invoked by the server but actually called on the client. And we call that a client RPC. So this goes out from the server. So commands and client RPCs are both remote procedure calls, but they're slightly different. There's a security model that says you can only call commands on your player object on the server. So, for example, you couldn't tell another ship to shoot a bullet. You can only tell your ship to shoot a bullet, and the commands enforce that security model. Okay, so let me build that. Uh-oh, failed. RPC respawn does not exist. Oh, I have to change my name. Okay. So now we should see when players, I forgot a step. So our client respawn function, we need to create an explosion. Because we want an explosion to happen on the client when the player dies. So I'm going to say make explosion. We'll make it a big explosion, so it'll last for 1 second. So another slight complication with this function, if I left it as is, the player would respawn on all the clients. We only want this to happen on the client that is in control of the player. Okay. So this is our host. This is our client. Now, if I shoot this guy, we just see an explosion. He exploded and he respawned in the right place, so that's good. And let's try this. Yep, and the explosion appears in the right place on both people. I have to wrap it up. Yeah, because we started late because of the keynote, it looks like I have to wrap it up. So I had lots more stuff to show. Let me just go through it quickly without any programming. So death and respawning. Then we were going to fix the aliens, fix the spawner so that it only runs on the server, and we spawn the aliens out. Then we're going to customize where the player gets added to the world using the network manager. And I was going to show you how to customize the network manager by overriding some of the base class functionality it has. Then we're going to hook up a scene, have an offline scene, an online scene, and do transitions between them. And that was the end of the demo. So then I have one small slide on future work. So in this serverless environment, one of the problems you have is if the server goes away, what happens? So the common solution to that is what's called host migration. So one of the other clients becomes the host. In some games that can be done, in some games it can't. If you have sort of data secrecy on the server, then it can't be done. But if your data is sort of symmetrical across all the clients, then one of them can become the new server. So we're looking to support that. We're looking at what we call an area of interest system to support different visibility sets of different clients, so that handles sort of like all the object visibility use cases like fog of war and stealth and visibility ranges. We have a bunch of low-level tools, integration with the Unity profiler, packet logging, network, simulating different network conditions and doing replays, and more online services. And those are the blogs that have already been published on UNet. Links to them if you can read them in that horrible blue color. And that's it. So thank you.